Hello everyone, myself I am Divya Prakash. I am currently working as an intern at Skillvita. As part of Internvita program, we developed a project called Wearable Pendant for emergency for triage. So the reason for selecting this project is to avoid the manual errors caused by manual entry by ambulance staff and to avoid the miscommunication over radio communication. So to overcome these errors and to save most of the lives, we developed this project. So basically in this project, whenever the ambulance staff assesses the patient condition, he sends the triage status to doctor over a dashboard. When the doctor receives the triage status of the patient, he alerts his subordinates to make ready the emergency rooms for starting the treatment for patient. So as part of this project, in the week 1, we gathered the hardware requirements for our project. So for this hardware requirement gathering, I have referred many of the journals available on the Google. So I searched journals related to these projects and I used some of the OpenAI tools such as ChatGPT and Gemini. So from all these, I finalized my hardware requirements for the project. So basically the hardware requirements are microcontroller and a button for manual activation, LEDs of 4 different colors, red, green, yellow and blue, indicating the triage status, and a battery for charging the microcontroller, and a charging module for charging the battery, and a voltage regulator to convert 3.7 volts to 3 volts as microcontroller works at 3 volts, and connecting wires for connecting the equipment. So the microcontroller I have been using is ESP32 since it supports Wi-Fi communication and BLE communication. So as part of week 2, we have designed system architecture for the project. So for this I used Walkway, a website which is useful to design the digital prototypes. So you can now see the digital prototype we have designed. So it also works once we start the simulation. So you can see with one press it changes the triage status to red, with another press it changes to blue, with another press it changes to green, and with another press it changes to yellow. So like this we can send the triage status of patient. So once we long press, it gets confirmed. So next we come to week 3. As part of week 3, we have designed a 3D design for pendant for where we store these components that are selected for our project. So for this I used a website called Tinkercad. So I have designed this pendant design as part of a 3D design. So you can see in this we'll store our equipment, and this will be our outer loop. And I have designed one more 3D design using Bolt AI. As you can see here, this is one more 3D design for a pendant I have designed. And as part of week 4, we designed schematic and PCB layout design for our project. So for schematic design and PCB design, I used a website called Easy EDA. So now you can see here on the screen, it is schematic design. So I used ESP32 and button and 4 LEDs of different colors, and I have integrated them using the connecting wires. And now you can see the PCB design for our project. So this is the work of week 4. So as part of week 5 and 6, we developed the project by gathering all the hardware components and by buying them, and we worked on it. So now you can see the code and you can see the hardware. So this is the hardware. Here this is the ESP32 microcontroller. This is a push button, and these are the 4 different LEDs of different colors indicating different triage status. Here red indicates immediate attention and yellow indicates a delayed attention minor attention of the patient, and green indicates the patient is all right, and blue indicates the person is dead. So you can see here, this is the page or dashboard which indicates the patient's triage status and triage description. So now basically the yellow light is on, so the triage status here is yellow, and you can also see the output on serial monitor here. So now you can see, on button press the triage status changes, and on long press the triage status gets confirmed. Yeah, now you can see, on button press the triage status gets changed, but in dashboard it does not get updated. In dashboard it gets updated only when we confirm the triage status. So for confirming the triage status, we need to long press the button. So now you can see there is yellow light which is glowing, and in dashboard the triage status gets updated to yellow, and triage description is given below. So this is actually the actual output of our work of our project, but we have 2 more weeks left out for completing our project, but we finished it 2 weeks earlier. So we thought of implementing or upgrading the project more. So for that we also added the speech recognition. Based on voice commands, it should change the triage status and it should send the data to the dashboard. So for that I used a deep learning model called Whisper, which is an OpenAI model. So using Whisper, I'll give voice commands. It recognizes that voice commands and converts them into text and sends the text data to the dashboard. So based on that command, here in this equipment, the light also changes. So the triage status also changes, and that triage status is confirmed and directly sent to the dashboard. So for this I use 2 codes, producer code and consumer code, as I am using the protocol RabbitMQ for data transmission and for data receiving. So for that I designed 2 codes. So in this I used OpenAI Whisper mode, Whisper DL model. In that I used a small model of Whisper, so for better accuracy. We have different types of available models, but small model gives better accuracy for single word commands or single line commands. So it will record for 4 seconds, and after recording and transcribing, it directly sends the command to RabbitMQ channel. You can see here. So the channel I have given here is triage commands. 1 second. You can see here. So the channel to which I am sending the data is triage commands. So once I give the command, once it gets transcribed, it is directly pushed into triage commands channel. So when we run consumer.py, it retrieves the data from the triage commands channel, and it stores the data as JSON format as part of output. So I'll show you how it works. So basically in one terminal we need to start consumer.py. So basically in one terminal we need to run consumer.py. So since we did not send any command or any message to the triage commands channel, so it is waiting for Whisper speech messages. So once we send the messages, it automatically receives the data here. It retrieves the data from the channel. It always be listening to that channel triage commands. So once we run producer.py code, the Whisper model starts and starts recording the triage commands. So you can see here. green. So you can see here it recorded the command I have given and it is transcribing now. So you can see here green. So you can see here I have given the command green. So once the recording is finished, I transcribe locally using Whisper. So once it is transcribed, you can see it is the consumer.py directly fetched the data, and you can see the data we have given in producer.py is green command. In producer.py we have given the command as green. So the data fetched is also green. Yeah, you can see it is stored in output. And once the command is green, the light here got changed, and we can also see in dashboard it gets updated. You can see here in dashboard also it got updated. Previously the light was yellow. On giving the voice command green, the green light is glowing. So as part of week 7 and week 8, we have implemented this voice control system. So now our project is both voice control and we can manually control it by using push button. So this is our project. Thank you.